Today we're going to talk about simplifying radicals. Now, this first worksheet is just to give you the basic understanding of it. A radical is any quantity with a radical symbol. A radical expression is any expression that contains a radical. And to simplify radicals means to perform every operation possible and to make the radicand or radicands as small as possible. Sorry, I didn't realize yours was cut off on the side right there. A square root C. A is a coefficient. This is our radical symbol. And C is our radicand. Okay? Radical expressions. Radical expressions in the simplest form if the following are true. No perfect square factors other than 1 are in the radicand. So we can't have any perfect squares, because if you have the square root of 16, we actually have the coefficient of, y'all can say it.
Oh, 4.
4. Okay. No fractions are in the radicand, and the radicals appear in the denominator of a fraction. So you can't have radicals in the denominator of any type of fraction, but they can be in the numerator. Okay? So, your A is your coefficient, then you have your square root or your radical sign, and then C is our radicand. Square root undoes a square. Now we know that. Now I want you to look at these numbers. These are going to be our magic numbers. Okay? We always want to start with our magic numbers when we go to simplify. What I like doing is I like factoring with my magic numbers so that it makes the process more simple. All right? But this one, let's look. Square root of 49. Most of us already know this one. Square root of 49 is what?
7.
7. So simplified, this is 7. Square root of 100 simplified is what? 10. Okay, you just simplified a radical. All right? So let's look at 32. So remember our magic numbers. Okay? What was my first magic number I need to look at? 4. Okay? Now this is the same process as factoring things out, all right? So if you... Okay. This is the same as 4 times 8, correct? All right? So it can also be written as the square root of 4 times the square root of 8. This is why we start with the magic numbers. Square root of 4 is what?
2.
So I have 2 square root 8. Can I simplify square root 8 anymore? Without no decimals. Can't have a decimal. Can we simplify it anymore? Because we can't use the perfect... Oh, can you? What is it? Huh? 4 and 2. Okay? So square root 4 times 2 is the same as saying square root 4 square root 2. So now what do I have? We can't forget about this coefficient. What do we have right here? Square root of 4 is what?
2.
2. Can I simplify square root 2 again? No. So I have 2 times 2 square root 2. What's 2 times 2?
4.
So 4 square root 2. Number 24, or number 4. Square root of 24. I know I can factor it into square root of 4 times what? 6. Okay. Which is square root 4 times square root 6. Can I simplify square root 6 anymore?
Yeah.
With my magic numbers?
Oh.
No. Okay. So we have 2 square root 6 is the answer. You have to make sure you're thinking about the magic numbers. If the magic numbers go in, you can keep going. Okay? So right here, we have square root of 9 times x times x times x. Okay, now, a square undoes a square root, right? So to be able to pull a square out, you have to have two of the exact same, right? You have to have pairs. Are you with me? So square root of 9 times x, because isn't this the same as x squared? Times square root x. Are you with me? You have to, your variables, you have to put them in pairs of 2, okay? So what is the square root of 9? 3. And then what's this? Just x. Why? Because you have x squared, and then we square root it, which is just x, right? Now, we've taken care of that, and we're left with square root x. Okay, so get number 6. So I have the square root of 25 times the square root of x squared. So the square root of 25 is what?
5.
And square root of x squared is? So the answer is 5x. Okay, so those are some simple examples. So let's go ahead and look at this other set of notes here. All right. Simplifying. Radicals with a product property. Simplifying radicals with product property. All right. To make sure we all understand, the radicand is this number, and the radical is that sign. A radical expression and simplest forms are what we had earlier, okay? No perfect square factors other than 1 are in the radicand. No factors are in the radicand, or no fractions are in the radicand, and no radicals appear in the denominator of the fraction. All right. So the product property of a radical state when square roots of a product equal the product of the square roots of the factor. Algebraically, this means if you have the square root of a times b, it is the same as saying square root a times square root b. A and b are real numbers. And greater than or equal to 0. No negatives. No negatives. You cannot have a negative underneath a square root sign. Steps. Factor using perfect squares. So what we're going to do, we're going to factor using the perfect squares. We're going to use the product property of radicals, and then we're going to simplify. All right? Oh, simplify. I got to write that in. Okay. So 12. Let's think about our magic numbers. 4 is our first one. So we're going to take it square root 4 times 3, which is the square root of 4 times the square root of 3. Correct? Which gives us 2 square root 3. Done. Okay? Now, What is one of our perfect numbers that can go into this next one? We can do 16 and 2, right? Square root of 16 times 2, which gives us the square root of 16 times square root of 2. If you use another number, like if you use 4, you're going to get to the same one. It's just a longer process like I showed you earlier. And then square root of 16 is what? 4, so it's 4 square root 2. Are y'all starting to see it a little bit? Okay. So move over here to number 18. 18 is what? 9 times 2, which is square root 9 times square root 2. What's the square root of 9? 3. So my answer is 3 square root 2. Are you okay? Okay. Now this one already has 1 in front, but that's really not a big deal. We're just going to leave the number up front. It's just one of our coefficients. So I have 10 square root 45. Do I use 4?
No.
9?
Yes.
9 times what?
5.
So now I have 10 square root 9 times square root 5. And 10 times what? What's square root of 9?
3.
That crosses off and gives me 3 square root 5. So my answer is what? 30 square root 5. Okay. The next one. All right. So 4 is on the outside and both these terms are in the inside. So what I'm going to do is I'm going to write it 4 3x times x. First, I'm going to combine my radicands together underneath that radical sign. All right? So that actually separates into 4 times square root 3 times square root of x squared. Now what can I do? Can I do anything with square root of 3? What can I do with x or square root of x squared? It's just x. So I have 4x square root 3. Okay, let's do the same thing on this one. So I'm going to put my 3 out front. I'm going to put everything else together. 7, and then I have an x and an x. So what can I write?
X squared.
X squared, y squared. So I have 3. Okay, I'm going to go down into this line and I'll write the other stuff here in a minute. Square root 7 times the square root of x squared times the square root of y squared. Okay. Can I do anything with the square root of 7? We're going to do anything with x squared x? Square root of x squared? It's x. The square root of y squared is? Y. So my answer is 3xy square root 7. Are we good? Okay, if you want to flip it over on the back, you can. I'm going to write what we have here. A summary of what we've done. It says the radical radicand is the number, bless you, it's the numbers and letters under the radical. The product property is square root a times b, which equals square root a times square root b. but A and B have to be greater than 0. D to simplify, radicals factor using the magic numbers. I'm going to put a slash perfect squares, because that's really what we're starting with. We start with those perfect squares, the 4, 4, 9, and then like 4 times 4 is 16, and then 25. Okay? Then we use the product property, and the last step is to simplify. Use the product property. And the last step is to simplify.